Welcome back. In this video, as it says here, we'll put it all together when it comes to turning points, relative maximum and minimums, and points of inflection. So let's take a look at our sample problem 8 here, and we've got a function y equals g of x shown at the right. Identify the characteristics. Known values for g are shown in the table below. So just looking at our graph, there's some things we know and we can see. We have the same end behavior. Both our left hand end behavior and our right hand end behavior go to positive infinity. So we should know this is an even degree polynomial. We might even know that this leading coefficient is positive. We see we've got some zeros or x-intercepts at -5, -2, and looks like 2. So we have some x-intercepts or zeros there. We've got some relative minimum. We've got a relative maximum. We have an absolute minimum down here at looks like -8. So we've got all sorts of good things going on here that we know. So we've got a decreasing function that turns concave up, and then after our point of inflection turns concave down. We'll have another point of inflection as it goes to concave up, and then we have an increasing function as well. So our function is going to begin from left to right by decreasing. It's going to increase and have concave down. Our function will decrease, and then it'll move to concave up, and then our function will increase again. So they gave us some exact values here. For x of -5, we have a y of 0, so that's an x-intercept. For x of -4, we have a y of -4. That happens to be the minimum point. We have an x of -2 and a y of 0, so another x-intercept. And it bounces at that point, so that's going to be a double root or a multiplicity of 2. We have an x of, well, I called it 1 and -8, but they have 0.9 and -8.1. And then we also have another x-intercept of at 2. So the domain of our function, what's the domain? Well, what are our valid x's? Our x's here, we can choose any x we want. We don't have any asymptotes. We don't have any holes. So our domain is all real numbers, so it's going to extend from -infinity to infinity. Our range, we notice we had an absolute minimum here, so our minimum y value is -8.1, and our maximum y value is infinity. So I'll write this correctly. -8.1 to infinity is our range. This is a 4th degree polynomial. We know that because we have 4 x-intercepts. Now you're wondering why I say 4. Well, there's 2 of them here at -2. So we have 4 x-intercept. So my notes here say this is a quartic or a 4th degree polynomial. The zeros and their multiplicity, we've talked about that. We have a 0 at x equals -5, at x equals -2, and that was our double root. That one had the multiplicity of 2, so it bounced. These other single roots is an odd, so that one, those will pass through. And we also have x equals 2. The intervals where g of x is increasing, we've even talked about that as well. Our function is increasing between -4 and -2. And then again from 9/10 to infinity. I might have called that 1. And our function is decreasing then, and we saw that, between -infinity and -4. And it is also decreasing, again, these are x values, the x values from -2 to 9/10. Our relative maximum, I think we had a relative max at a y value of 0 and an x value of -2. So -2, 0 would be the ordered pair. Our relative maximum would be y equals 0. We had a relative minimum at -4, -4 at that ordered pair. So at y equals -4. And then we had an absolute maximum. Well, there isn't one. There is no absolute maximum because of our end behavior. These guys both go off to positive infinity. So there's no absolute maximum. There is an absolute minimum. That was at y equals -8.1. I think that was the ordered pair 0.9, -8.1. We have some inflection points. If I remember correctly, we'll use rule 2. We can find the inflection point between the minimum and maximum points, or between the maximum and min. So I've taken a moment to write those ordered pairs in, and we will just do our midpoint formula here to find the inflection points. So the average of our x's, -4 plus -2 over 2, and the average of our y's, -4 plus 0 all over 2. So -3, -2 is one inflection point, and the other inflection point, -2 plus 1 over 2, 0 minus 8 over 2, and that would be at -1/2, -4. The intervals where our graph is concave up, that is going to occur here from -infinity to our inflection point, and again from our other point of inflection to positive infinity. So for x values, that's going to be from -infinity to -3, and then also from -1/2 to positive infinity. And then the interval where it's concave down is going to be between those two in points of inflection. So the x values here from -3 to -1/2. And there's a sample problem that ties all this together, and we'll get some more practice with this when I see you in class.